We are now going to think about representing, so drawing pictures of transverse waves. We'll do longitudinal waves after this, but it's easier to think about transverse waves. So what makes waves challenging is that we have to think about both time and space. When we go to do the math of this, it's going to be a function of both position and time. So what that means is we're really thinking about a function of two dimensions. So we actually have to draw a representation, if we wanted to really capture all of the information, that is three-dimensional. That we have a one dimension, which is going to be position. We have another dimension, which is time, but then for every single spot, right? So this represents a specific position and a specific time. There's some displacement that corresponds to that spot, which we'll talk about more mathematically later. So this is pretty hard. We have a function of two variables, which means we have to do a three-dimensional representation, and we really can't draw both of these. The book can give us a picture like this, and we can kind of see that we have this pulse that is in later time at greater distances. So one thing that's a little bit helpful to see in this picture is that it looks like our pulse is keeping an identical shape, but is just moving at greater distances for later times, and we see our travel there. But how can we, as human beings who maybe aren't great artists, actually represent this? We're going to have to break it into pieces and show what's happening in position or what's happening in time. So we're effectively taking either one position and looking at what's happening over multiple times at that position, or we're taking one time and looking over different positions. So we're effectively taking a slice through this to plot it, and that's then going to be much easier for us to draw. So a snapshot graph is when we're looking at one moment in time, and we're then showing a range of positions. So our time here needs to be specified about what time we're actually looking at. The positions then is just your horizontal axis. Your vertical axis is going to be the displacement. So in the case of a transverse wave, remember that's what we're talking about, our displacement is going to be vertical while our wave speed is horizontal. So effectively we can imagine a wave on a string. This doesn't have to be, this could be a water wave or a different type of wave. But if this was a wave on a string, we would literally see the pulse at one moment in time because the pulse is moving, and that is what our snapshot graph looks like. So this really looks like the wave we're talking about. So a snapshot graph is the easiest thing to think about. It's for one moment in time, what is the displacement, here vertical, compared to your position, which is your x direction, which is along the medium itself. So this pretty simple to think about. But that's not the only type of plot we're going to make. We can now think about what mini snapshots are going to look like. So this is a different way of looking at that 3D plot, but instead of having them be kind of time be on a different axis, we can just show multiple times. So note that again in this case we see that the shape of our pulse is preserved. It always looks the same. And you can then actually track one point, right? So this one point is here, this x1 point. We see that it starts at a certain displacement. At a later time it's higher, and then at a later time it's lower. So it's really first going through this edge of the pulse, and then marching along to further. So for instance, between this time and that time, somewhere in there, that point x1 was at the peak. So this would be one way to actually show what's happening over multiple periods of time to that pulse. You may or may not want to draw one of these depending on if you're thinking about what's happening with a pulse over multiple moments in time. It's not always going to be necessary. A history graph is actually going to be a plot now in time. And so in order to do this, you have to pick one location in space, and you should actually specify what that is. And depending on the type of problem, you might want to do both a snapshot graph, the one of position, and the history graph, the one in time. So this again is going to show us a window in time, which then is again our horizontal axis. Now the vertical axis is displacement. This is again just like what it was on the snapshot graph, but something to notice is that it's going to look reversed from the snapshot. And the reason for that is that this is what happens first, and then this is what happens later. So remember that when we watched our point moving up and down, it first moved towards the leading end, what we would call the leading edge of the pulse, and then towards the trailing edge. So this happens first, and then that happens. And if we were talking about a pulse moving to the right, the leading edge was before on the right. So you should ideally be able to think through why this looks like a mirror reversal of the snapshot plot, but that's actually correct. It should be like that. So to show another comparison, if we have this sort of a pulse traveling to the right, notice that this snapshot graph, so snapshot means position, it specified what time it's at. We have a history graph, its time, specifies what position it's at. The reason this is then interesting is we can take that position and look here. Now notice that at time equals 0, our pulse isn't to a position of 8 meters yet. What that means is here, this is 0, right? We have no displacement. But this pulse is going to march to the right as we start marching to the right in our time. So based on the speed, if this is moving at 2 meters per second and it needs to go from 4 to 8, that's a delta x of 4, it takes 2 seconds for this edge of the pulse to reach 8 meters. So the first time that anything happens is 2. And notice, again, as the first thing that happens is that it will go down. I'm not very good at drawing. And then up, right? That's what's going to happen at t equals 2 seconds. So again, the first thing that happens is the down and then the up as our pulse again goes a little past like that. So again, you see that the history graph is reversed because again, this reaches it first, which occurs at earlier times. So two different types of graphs here. Frequently you're going to want to use them together to really show what's happening.